Hey everybody, welcome to the second episode of Aviation with Queen. Today we'll be discussing aerodynamic basics, which is basically lift, weight, thrust, and drag, but we'll just go a little bit deeper into how these four components come together to help the plane fly.
Yeah, set apart, covered and blessed. I serve God and say it with my chest. Wake up, thankful for his patience, grace, and
So what is aerodynamics? So aerodynamics is the study of how air interacts with a moving object. So in our case, it's how air interacts with the aircraft. It's important because it teaches us how a plane lifts off, stays in the air, and lands back on the ground safely. It shows how the air interacts with the aircraft and how the four forces, lift, weight, thrust, and drag work together. So first, we're gonna talk about lift. Lift is the force that makes the airplane rise. It happens when air flows over the wing in a way that creates an upward force. And there are some factors that do affect lift and how a plane is lifted into the air. So we have an airfoil shape, which is basically the shape of the wing, and we have your angle of attack, which I'll tell you the definition, but we'll get more into that in a next video. And then we have airspeed and we have air density, which is just basically your pressure and your temperature changes. The next factor that affects lift is Bernoulli's principle. And Bernoulli's principle is faster air pressure over the wing creates a low pressure, lifting the aircraft. I know it might sound a little bit complicated, but I drew it out for my visual learners, and I also have another example for you to try to make it a little bit easier to understand. So first, let's get into the drawing. So here we have our direction of flight. We're heading this way. And so when you're heading this way, of course, the wind will be flowing towards you. So here we have our high velocity airflow, which flows this way over the wing, which creates a low pressure, and that low pressure is faster air. And then on the bottom, we have a low velocity airflow, which flows underneath the wing, creating a high pressure, slower air. And those two pressures, of course, they're different, higher and low pressure, and that is what causes the aircraft to lift over the wing. As you see here, the high velocity airflow goes over the wing, creating that low pressure, and the low velocity forms that high pressure, which creates lift. So another example I have for understanding Bernoulli's principle is basically this. So say we have a straw, and then we have a piece of paper, and we blow through the straw like that, but we put the paper on top of the straw while we blow through it. What's gonna happen to the paper? Let's find out. You saw the paper, it floated just a little bit. It didn't do as much as I would like it to do, but that just shows like the low pressure over the top and the high pressure on the bottom creates a pressure difference, which causes the paper to lift. And the final factor that affects lift is Newton's third law, which states for every action, there is an equal and opposite reaction. And this one, I also drew it out so it can make a lot more sense. So as we see here, this is a poorly drawn wing, but this is our wing. And as the air is flying through the air, we know airflow is being deflected down. And that would be our action as Newton's third law states. And the reaction that we get to this is the airfoil being pushed up. The air is pushing back up with the equal and opposite reaction, which is causing lift. Another example of showing Newton's third law could be like, if you are say you're pushing on a wall, and you're pushing on this wall, but the wall is exerting an equally and opposite force, which is preventing you from moving this wall or pushing through this wall. And that's also Newton's third law. And we see how that ties into, because it's very similar to how the wing is pushing the air down and the air is reacting with that equal and opposite force, which is pushing the wing back up, creating lift. So the next force that we're going to talk about is weight. Weight is the force that works with gravity and pulls the plane downward. And this force also counteracts lift. And some key components that affect weight is our fuel burn, our center of gravity, and our payload. So when we say fuel burn, the fuel burn is basically like as we're flying through the air, we burn fuel. Just like in a car, you burn fuel. So that would affect, how much the plane weighs, because it would be heavier with more fuel, lighter with less fuel. And then we have our payload, which is our total weight of everything, including like our passengers, including if you're bringing bags on the plane, including if you're bringing anything that's inside of the plane, that will be your payload. And then our CG location, which is your center of gravity location. Your center of gravity is just basically the place that the plane is balanced evenly. So those are just some factors that affect weight. So the next factor is going to be thrust. And thrust is what moves the plane forward from props or the engine. And some factors that affect thrust, we can have an engine power. So if you have a weaker engine, you'll get less thrust because the engine can't produce enough thrust just because the engine's not as strong. And then you have your airspeed. If you're at a lower airspeed, you may not get as much thrust just because your airspeed is low or slow. And then you have altitude. If you're at a higher altitude, at higher altitudes, the air is less dense, which is also something I will go over in a later video. But at higher altitudes, your air is a lot less dense, therefore the engine won't be able to produce as much thrust in these higher altitudes. And then we have a temperature, which also ties into like altitude. When it's hotter, their air is less dense, so it creates less thrust, versus when it's colder and the air is more dense and you will get more thrust. The last force that we're going to talk about is drag. And drag is air resistance that tries to slow the plane down. And this force, it also opposes thrust. And then with drag, we have two types of drag. We have parasite drag and we have induced drag. So with induced drag decreases with airspeed, and our parasite drag increases with airspeed. In parasite drag, there's a couple types of parasite drag. So we have form drag, which occurs on any object. We have interference parasite drag, which is two or more currents of air meet and interfere. And then we have skin friction, which is created by the roughness of the aircraft's skin. By understanding these forces, pilots can control the aircraft, make smooth turns, and fly safely in any type of condition. Without aerodynamics, flight wouldn't even be possible. And that's all I have for you for today's video, which was just a little bit more of aerodynamics basics. So if you like this video, be sure to like, comment, and subscribe. My next video, my birthday is on Friday, woo! So I will be doing a birthday vlog for my birthday. I have a lot of plans. It's gonna be super exciting. So you're gonna wanna subscribe and stick around for that one. I hope you enjoyed this video and learning with me, aviation with Queen. I will see you guys next time.
And we say